So here's the problem of the day for the lesson 2.6. Read it and answer it. Today we're talking about 2.6, which is draw scatter plots and best fitting lines. This lesson is another lesson that's very applicable to real life that mathematicians use for data and other things in the real world that I'll talk about as we go, and you'll see that in the problems here today. So let's start with the basics. It's a scatter plot. It's a graph of a set of data pairs x comma y. Now, I mean, if you just glance at the bottom here, you'll notice that it's actually not one straight line. A lot of data that you get in information will never be perfectly linear, so we call it a scatter plot. Positive correlation, if y tends to increase as x increases. If you look down here, this is positive correlation. I think it has positive slope, right? From left to right, it increases. Negative correlation, if y tends to decrease as x increases. So if you go from left to right, we're going down. Also like a negative slope, right? And I wrote a note here, if the points show no obvious pattern, then the data have approximately no correlation, which is the one at the end here. Can you see sort of that the points are all scattered about? All right, now knowing that it's, positive, negative, no correlation, let's take a look at the first example. And like I said, you're going to see a lot of word problems and data here throughout the lesson. In the first example, I talk about telephones. It says, describe the correlation shown by each scatter plot. And actually, this is very applicable as well, because if you take a look, it very well could be someone's job to count the number of cell phone subscribers in cellular service regions. All right, any company, if they want to invest money, they're going to pay someone to do research for them. So say we're looking at, I don't know, Verizon. Say Verizon keeps track of how many cell phone subscribers they have and how many regions they have. Remember, more of a region of cellular service means you have more of a connection. So that means, like, how if you ever go somewhere that's really rural and there's a dead spot, clearly they don't have enough like cell towers. So if we look over here, it goes by how many regions in the thousands on the y-axis and the subscribers in the millions along the x-axis. And I would say this one is a positive correlation, right? And that makes sense, right? That the more people they get to subscribe to cell service, the more regions you have to accommodate those people. Now let's look at the other one, cellular phone subscribers and ported phone sales from 95 to 2003 as well. If you notice, this is a negative correlation, right? And that also makes sense because as time goes on, the more and more people have cell phones, they sort of start to do away with corded phones or landlines. Like I know even myself, I've had a cell phone probably since I was like 16. So in college, I didn't have a landline, and now I don't have a landline as well. All right, but that makes sense. That's a negative correlation because the more and more we get cell phones, we tend to sort of phase out the landline. All right. Example. Now the next part here, before we get to example 2, I should say, is talking about a correlation coefficient. Now sometimes, remember, it's a correlation, positive, negative, or no correlation. So the points aren't a linear or straight line, right? So we have to take a look at how close the points are. Yeah, it might be positive, yeah, it might be negative, but how close are they to almost to a line? So correlation coefficient denoted by R, a number from -1 to 1 that measures how well a line fits a set of data pairs. All right. So, okay. So we start with -1. That would be a negative correlation. And I'm going to type this here. You guys could add this as well. Points lie near the line with a negative all right. So if it's a -1, points lie near the line with a negative slope. If it's a +1, points lie near the line with a positive So if it's -1 or +1, it's an actual slope, straight line, how close it is set. Now what if it's 0, like no correlation? All right, well that has one too. Points do not lie near any line. Right? Now, what that means for this next one, let's take a look at that with example 2. It says, tell whether the x and y have a positive, negative, or approximately no correlation. Then tell whether the correlation coefficient for the data is closest to -1, -0.5, 0.5, or 1. Now, where did we get the -0.5 and +0.5? If it doesn't fit, if it's not perfectly a straight line, positive or negative, all right, it's sort of in between. So let's take a look here. All right. So for letter A, I'm going to write it to the right of it. I know I don't have a lot of room here. If I take a look, it's not very good, but it is positive. All right. Positive correlation. Write the word correlation after it if you want. Now, do you see how they're not really close together? I would set to positive 0.5 as my line. All right. And how about for the next one here? We know it's negative, right? Now this one I would call -1. It's not exactly a straight line, right? But you see how close the points are together? And then the last one here, squeeze it over here. It's going to be no correlation, none. And I would call this one 0, purely for the fact that if you take a look here, there's just a whole bunch of points on the paper or on the notes here, and they don't make a line. All right. So best fitting line, how do we do this mathematically? What if we want to actually solve something? The line that lies as close as possible to all the data points. So how do we solve them? All right. Number 1, you guys can write this down and draw a scatter plot of the data. So you plot the points. Step 2, we're going to sketch the line that appears to follow most closely the trends given by the data points. There should be about as many points above the line as below it. That is very, very important. You're going to draw a line. You're not connecting all the dots. You're going to draw a line that fits most of the points. All right, that's in the center of them. All right, so then the next one, choose 2 points in the line and estimate the coordinates of each point. If at all possible, try to pick points exactly on the line. These points do not have to be the original data points. All right, so I like to find points that are right on the grid that I don't have to sort of try to figure out what they are, and you'll see that as we go through the examples. Last one, write an equation of the line, passes through the 2 points from step 3. This equation is modeled for the data. So we're doing what we did back in 2.4, write an equation of a line. All right. So let's start off one where I already give you the line. So you have all your points here, right? And you have a nice straight line through it. Approximate the best fitting line for the data. All right, so what I'm going to do is I want to find 2 points that are right on the line. And if you take a look here, I have this point and this point. But here's the problem with it. You see how you would have to estimate. They're not on a nice grid like on a corner. So I'm actually going to pick something different here. If we take a look here, I actually like this point that's below here. Let me fix this here for a second. Right here. You see how it's right on the grid? You guys can see that, right? And then the other point I like is right here. So you might want to take a second to draw these 2 points on there. So you don't have to use the points that are in the line. You could. You see like how this one, now when you pick a point, you want it to cut right through the center of it. But this one I'd have to estimate because it's in between the grid here. So that's why I don't like that one. Or this one's nice because it's right on the center, right? But it's in between the lines here. So I would actually pick drawing 2 points that fit nice and neat, and it makes our math a little easier. So these 2 points that I wrote, we're going to actually Find out what they are as an ordered pair, and we're going to do the equation of the line. Now be careful, we're going by halves. So this is 0.51, 1.52, 2.53, 3.54. All right, so we go 0.51, 1.52. So this is 2, comma, 1, 2. So the first point on the left I'll do first. It's 2, comma, 2. And then my second point, double check it, is 4, comma, 0.5. So that's it for the best fitting line for the data. Now you're just going to solve like you've done before in the previous lesson. Find your slope, m equals 0.5 minus 2 over, I'll draw a line in it in a minute, 4 minus 2. Which is going to equal negative 1.5 over 2. And I'm going to simplify it because I don't like it as a decimal and a fraction. Let's do negative 3 over 4. And I'll put a little line between them. It's a little bit easier this way. All right, so there's my math to it. So here's my slope. Okay. So next, we got to find the y-intercept. I'm going to use the first point. We could solve as well. So b equals 3.5, or sometimes I like to switch it back to an improper fraction, sort of like slope. So there's my b. Finally, plugging them back in, what do I get? Y equals negative 3/4 x plus 7/2 or plus 3.5. And always check, like what do I mean by that? Always check that. That makes sense. All right, so I have a negative 3/4 slope. That makes sense because it's negative here. 7/2 are 3. If you go up here, you'll see that's about 3.5. All right, so check your work. Now here's the thing with these. Our answers are going to be close, but no two people really should have the same exact answer because we all can pick different points, and you'll see that as we go along here. Okay, so let's look at the next one. Now we're going to make a scatter plot and do everything as well. So plot your points here. All right. So what's different with this one? We're going to plot the points, and now we're going to do the same exact thing again. So I'm going to draw a line of best fit. A ruler is going to come in handy. So let me see what I have here. I want to use and like I could use mine here, right? Okay. So I want to use a ruler to sort of figure out where my points go. Where you want the line in the middle of all of them. So let's see if I can at least start moving this over. All right. So you're going to see in a minute. Let's see. It's being temperamental here. It doesn't like me. Just a little more. I want to get it where, and using my clear ruler, you can sort of see here. I want to draw a line where the points are in the middle here. All right, so you see with the ruler, I finally got the points. Now it's clear at least, so you can sort of see, what do I have? I have 2 points above it and 2 points below it. So that looks actually like a pretty solid line here. So I'm just going to draw my line all the way across. And there's my line. Now, you want to use a ruler or straight edge, something, or the side of a piece of paper or something to get it nice and neat. Now, the thing with this is nice. I have 2 points above and 2 points below. Make sure it's in the middle. On a test or quiz or on a project, you're going to lose points if your line's not exactly in the middle, or as close as you can. All right? Pick 2 points. Now, honestly, you can pick whatever you want. I just picked the first two. In this case, I don't have to estimate where a point is. I have nice points right on the grid, cutting right through the middle. So we'll find our slope. Like I said, I'll fix this again in a minute. Actually, let's delete this one up here. We don't need that. Oh, one little thing I have to fix here, that's a negative. So negative 1 plus 2 is a 1 here. Sorry about that. Okay. And what we'll get in the end is just negative 1, right? So that's my slope. Let's put our little lines here. So you see the slope. So use negative 1. And then we're going to use one of the points. I'm just going to use, I'll use the second one this time. If b equals 1, my equation is y equals negative 1x plus 1. And once again, what I want you to get in the habit of doing is checking it. So what do I mean by checking it? I mean, look at your actual line. You know how to read the graph from a line. So actually my y-intercept is positive 1, right? I go down 1, right 1. So my math matches up with my actual answer. So equation of the line of best fit is y equals negative 1x plus 1. All right? So one last problem in the notes here. Example 5. So now we're doing everything here. All right. So the table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. A, draw a scatter plot and describe what relationship exists within the data. B, draw a line of best fit. What is the equation for this line? Okay, so I want you to pause and actually plot the points and answer letter A first. We'll do one part at a time. I'm going to pause the video actually and put all my points up there so it's not taking too much time. All right. All right, so like I said, this problem actually, what's nice about this is here's a real life example of how we can use line of best fit. We're looking at the predicted annual cost for a family to raise a child from birth until adulthood. So here's something where they hired statisticians or mathematicians to get some information, do some surveys, polls, then compile their data. All right, so here's all my points. I drew the scatter plot to describe what relationship exists within the data. So what would you say? I'd say it's a positive correlation. Can't spell that today. And actually, I'd say it would be about +1 for the correlation coefficient. It's very, very close. All right. Now we're going to draw a line of best fit. What would the equation be for this line? Once again, I'm going to try it first. All right, so I took a minute here to get my ruler set up, but here's my ruler. And because it's clear, you can see there's like 1 point below, 1 point above. Actually, 3 of my points are on the line. So let's draw our line. All right, close this. And that's nice. I have everything 3 in the middle and 1 point on each side. All right, so I'm going to use these 2 points. You can use whatever you'd like. I'm going to find my slope. I want you to try this yourself. I'm just going to give you my slope that I get. And I'm going to tell you what I get for my B. I don't have a lot of room here. But make sure you could get this as well. I think by this point we should be pretty familiar with using this equation to solve, right? So make sure you can actually get this. But here's the equation of my line. Y equals $566.67 times x plus 8,200. All right, that's my equation for the line. And these are the 2 points I used. So that means what? Every year you pay almost, what, $567 for every year of their age, all right, or of their life. The last part, a lot of times we like to do predictions. Predictions is, well, what happens at this point based on the graph of the data. So x is 18. So what we're going to do is we're going to plug in 18 for x and solve. And what you're actually going to get, if I move all the way over here, is $18,400 for annual cost. Move this cursor here. So that's actually a big amount of money, right? Annual cost for a child who's 18 years old is $18,400. That's a lot of money, isn't it, per kid? So we'll also use predictions for it, okay? So the last part, I'm only giving you one problem. I'm giving you a problem of the day, and then I want you to finish this whole problem from scratch, just like the last one, and we'll pick up tomorrow. All right, guys, good job today.